And we are on our way if we are recording. Like I said earlier, welcome to our last class in this course on Trigonometry Foundations. This course was here to help you catch up on any grade 11 trigonometry you might have missed, and to make sure that you have a good understanding of the basic ideas of trigonometry so that you can tackle the grade 12 trigonometry with confidence. We have had today's our 10th lesson in this topic. So like I was saying to Ms. Coco, we've been working hard, and I hope you have benefited from what we've been doing in this course. I have most certainly enjoyed teaching you. And next week we will be carrying on with our foundations. We will be doing analytical geometry. So I really look forward to seeing all of you for analytical geometry again. Ms. Coco and I will be taking you through that as well. In that course, just a bit more to give you a bit of a preview. In that course, we will also be doing some foundational ideas, but we will also be getting to some of the concepts from grade 12, which is circles and tangents, and finding equations of tangents to circles. Right, so that's that for today. Before we carry on, let's welcome any new people. Any new people, please put your hand up so that we can see who you are, and so that we can give you a special wave to welcome you to this class and to what we do here at Watobe. Anyone new today? Please put your hand up. Are we all veterans? Wow, okay. That's interesting. Okay, so as I was saying, one more announcement. Sorry for that. Let me just get to this announcement here, which is that we are going to be having exam prep classes on the 14th of May and the 21st of May. That is for June exams, if your school is having June exams. And it will be for an hour and a half from 3 till 4:30. That is a Saturday. It is at an additional cost of $199 for both, and space is going to be limited. So make sure you get a spot. It will be kept relatively small so that you get a chance to ask lots of questions and get the support you need before you head into your June exams, which is your first go at writing exams in grade 12. Okay, for those of you who might have missed a lesson, remember the recordings are up on our website, and you are welcome to access previous recordings and previous quizzes there. Today is again quiz day, so we will end off our lesson today with quizzes. So I look forward to seeing your results and seeing some of your names up. Remember, on a Tuesday we do shout outs, and hopefully we'll see some of your names there if you do really well on the quiz. But remember, it's what I call a low stress quiz. So you take your time to do it, you get multiple attempts. The idea is just that you practice and learn and try and improve. You can attempt it as many times as you like. I see some people have tried some quizzes 17 times. So I think that's the highest number of attempts I've seen. So feel free to beat that number. But yeah, it's definitely a low stress quiz. It's not something that we want you to stress about, but rather take the opportunity to see how you're understanding and how you are progressing. Okay, right. So let's then have a look. So we didn't quite finish off what we started last week in our lesson on trig graphs. This is where we were. We started just talking about the idea of what an amplitude is and what a period is. So we still have to look at the vertical shift and the horizontal shift. So those four things are the way in which trig graphs can be changed. So I remember, if you were here, I sent you away and I said, your homework is to take your textbook and to study your basic trig graphs, your sine, cos, and tan graph. Make sure you are very familiar with the characteristics of those graphs, their shape, their period, for tan, the asymptotes, and for what was the other thing? Yeah, so the turning points and the x-intercepts. Those were the things that I asked you to focus on. Okay. So then we started talking a bit about reflections and amplitude changes and how we recognize those in the equation of the graph, and also by looking at the graph. So we see an amplitude change when the graph is higher at its peak than what it is normally. And when I talk about normally, it's when it's just the basic trig graph. And as I explained as well, it's very good for you to, it's much easier for you to do trig graphs if you can, if you are aware and very familiar with the basic trig graphs, because then you can recognize if they've been shifted. Okay. So we were talking about the period, and what we describe as the period was how long it takes for one pattern of the graph to complete. So normally for a sine graph, it's 360, and the same for a cos graph, and for a tan graph, it's 180. So if we change the number in front of the x, that is normally, that is when you change the period. And that normally, how you can calculate your new period is by taking what your period usually is for your basic graph and then dividing it by that number in front of the x. Okay, so that's where we ended, and I think we're just going to continue with that and look at another example of the tan graph. And here the tan graph, the period, the number in front of x is a half. So that indicates to us a period change. So that basically says in the normal period, which is 180 degrees, there is half a tan pattern. So how long will it take? How many degrees will it take for a full tan pattern to complete? So our normal period is 180. So to calculate our new period, we can say new period will be our usual period, which is 180, and divide that by a half. And 180 divided by a half is going to be 360. So that means that my new period is 360 degrees. Okay, if you are having technical difficulties, Ms. Coco is there to assist you. And Ms. Coco, I got a DM from Nokolo. Maybe if you can just assist her with her audio.
Okay. Can Nokolo just DM me? That would help a lot, so I can see.
Yeah. Yeah, so just while we are talking about DMs and stuff, if you are having technical difficulties, you can message Ms. Coco and she'll be able to assist you. And also remember, pop your questions in the chat as well as your answers to any of the exercises that we do. And keep the chat clear for those purposes. And we prefer that you don't engage with each other or make any other comments, just maths talk, questions and answers and comments about the lesson. Okay, so back to our tan graph. So we can see that the new period is 360, and that's how we can calculate it. Okay, so that's the period. I'm going to move on to the vertical shift and the horizontal shift. So we recognize the vertical shift in the, I'm just going to zoom in a little bit. This might be a little bit small. So we recognize the vertical shift if there's a number added to our trig graph. So in this case, a plus q. So that q just represents any number that might be added to it, and a plus q here. So a vertical shift means either up if it's a plus q, or down if it's minus q. Q just representing any number. And here we've got y is equal to sine x plus 1. So that is a vertical shift up by 1 unit. So up by 1 unit. And cos x minus 2, that is downwards by 2 units. Okay, and here's one more example, cos x minus 1. So as you can see, and hopefully if you did the little bit of homework that I gave you and you studied your graphs, this will be your normal cos graph in its normal position, your basic function. And if you know your graphs very well, then we know that it normally has a minimum at minus 1. So if the minimum is now at minus 2, that's an indication that it has shifted down by 1 unit. So that's how we end up with cos x minus 1. Okay, can I get a thumbs up or a thumbs down in the chat, just as an indication of how you're understanding amplitude, period, and vertical shift? We've got 1 thumbs up so far from Dao. Chandra's agreeing. Thank you. Good stuff. Valerie also with us. Wonderful. Thanks, everybody. Okay, then our last job is to look at the horizontal shift. So the horizontal shift is when it's very important that you recognize the difference. So here we have the plus q just added to the graph. And here we have this minus q with the x in a bracket. Okay, so if it's a theta or a x, whatever your angle is, if it's with your angle in the bracket, it means you are shifting your graph left or right. And the left and right is totally counterintuitive. So if for this graph, for instance, x minus 30, that is actually a shift 30 degrees to the right. $30 to the right, and this one will be 45 degrees to the left. So if we're subtracting from x, we're moving the graph to the right, and if we're adding to x, we're shifting it to the left. Okay, so it works in the opposite direction. You might think that subtracting means moving it left, but it's actually in the other direction. Okay. Now, how to plot these? Normally, you can just do it with your calculator, but it is also really useful to just do it relative to the basic trig function. So what you can do is start by plotting the original curve and then move the critical points. Now, what do we refer to as critical points? Critical points are your turning points and your intercepts with the x-axis. Those are critical points, turning points and intercepts. And then once you've moved them to the left or to the right, then you label the x-intercepts and the turning points, and calculate and label the end points and the y-intercept. Okay, now that's a mouthful, but let me show you how that what all of that just actually means. So here we've got cos of x, and that is the solid graph. Okay, we can see it's in its normal position, unshifted. Now, normally the cos graph cuts the x-axis, the x-axis, in certain points. So this point here, for instance, that will be 90. And this one here will be 270. And then this one will be minus 90, minus 270. Okay, so that's what I mean with you have to know your graph very well so that you know how to shift it. Just going to choose a thinner pen so that we can actually see a bit better. Okay, so if we are shifting the graph 45 degrees, so here's my new equation, and that's the dotted graph. I'm going to make that blue. Okay, how did we come up with that graph? Well, we take the normal cos graph, the purple one, and we shift it 45 degrees to the left. It's x plus 45. So all those critical points are going to move 45 degrees to the left. Just going to make it even a little bit bigger so that you can zone in better. So that means if this was my original point where it cut the x-axis, it must now move 45 degrees to that side. And if this was 90, it moves 45 degrees as well. And this goes 45 degrees to the right as well. And the same with this point here. Okay, and that really is the easiest way to do it by referring to the original graph. Okay, let's take another example. Here is sine x minus 30. So the solid line is the sine graph, and we know the sine graph normally, first of all, let's look at how it's been shifted. So sine x minus 30, so it is moving 30 degrees to the right. So if we start here, and normally the sine graph goes through the origin, then it must move 30 degrees. So this new point will be 30 degrees. And then this one will be 210 because this original point is actually 180. And then finally, this one here will be 360 on the original graph. And if it is moving 30 degrees that way to the right, you will actually end up with a new endpoint, which you can calculate. So this is how you calculate your endpoint. You say sine 360 minus 30, and that is -1/2. So you just put that into your calculator to find this. Calculator work. Okay, so that is quite a mouthful. Let's do some practice. Okay, and for these given graphs, I just want you to write down the amplitude, the period, just the amplitude and the period. Let's not worry about the range and domain for today, just the amplitude and the period. I would like you to write down what that would be for these 4 graphs. I'm going to give you, let's say, 3 minutes to do that. As soon as you have all 4 answers, please pop them in the chat. Where's our answers, guys? Yo, your time is up. Please put your answers in the chat. There we go. Wonderful. I'm going to wait for a few more answers to come in before I give the whole game away. Jared is also putting his claim in here. Also stepping onto the pitch. Anyone else? Let's see. Who else is there? Who can we pick on? Maybe it's time to pick on a few people. Oh, let's get quickly some answers come through, yeah. Aisha and Anza, Ashanti, let's get your answers, guys. Brendan, Buchle, Chandra, we haven't heard from you this evening. Elizabeth, Itumaleng, Jessie, King Zooks, you also quiet this evening. Let's get some answers. Shanice, yeah, well done. Well done. Come, we want to see what you think. We need to crack these graphs this evening. This is our last shot at the grade 11 stuff. Period. Okay. Okay. Let's not keep people in further suspense. Okay, so for the first one, if you said that the amplitude was 2, that would be correct. The period for this graph has not changed. Remember, the question asked for amplitude and period. So you had to give the period. So period is 360. For question number 2, we can see that there's a 2 in front. So the amplitude is 2. And the period has also changed because the period, there's a 2 in front of the x. So we can calculate our new period by dividing the normal period by 2, and that gives me 180. I see a few 180s here. If you didn't get 180, remember you have to take the old period or the usual period, 360, and divide it by that number in front of the x. Right, some of you are looking good answer-wise. Amplitude is 3 for sine over here because the 3 has changed. And here, careful not to be caught out, there is a half in front of the x. So the period equals 360 divided by a half. And 360 divided by a half is 720. Fred is asking, would you divide by 3 if it was 3x? Yes, absolutely. You got it. That's how it's done. Okay, so the amplitude for tan. So tan's amplitude officially is undefined. But if you said 1, that is okay because you were looking at the number in front of the tan. Okay. Then the period for tan, there's a 3rd in front of the x, so we have to take the normal period and divide it by a 3rd. And I saw quite a few of you got that one right. That's 540 degrees. Okay, so give yourself a mark out of 8, and I hope that went well for you and that you at least got 50% for that. Okay, let's carry on to more of a type of example that you might see in a test or an exam. Asha, you can unmute yourself and ask your question.
Ma'am, so is the amplitude of a tan graph always undefined?
Yes, so the actual amplitude is undefined because it actually just carries on and tends towards the asymptote. But to say that A is 1 is also not wrong because the number in front of tan is a 1 in this case. Yes, Rihad, all tan has a period of 180 if we haven't changed the period. How do we know? There's a half in front of x over 2 because dividing x by 2 is the same as multiplying by a half. X over 2 is a half x. X divided by 2 is the same as multiplying by a half. Okay, let's have a look at this next question. So we are given, in this case, we are given 2 graphs. We are given the graph of sine x plus p. So immediately, you must realize that, okay, there's been a horizontal shift. And g of x is cos ax. So cos ax means that there's been a period change. Okay, so we have to determine the values of p and a. And we have to give the period of g, and then there's a little bit of a maybe like a complex question at the end about determining the range. But before we get to question 3, I just want you to answer as best as you can. Take 2 minutes and answer question 1 and question 2. And again, pop your answers in the chat if you are ready. Oops, there I might have just given it away. Let me shrink this. Pretend you didn't see, okay? Just pretend you didn't see. And if you did see, try and understand how this happened. Make the graph a bit bigger. Shall try and do that without making the answers bigger. Is that okay? Okay, pop your answers in the chat when you're done. Masha says P is 90. Let's see, does anyone agree or disagree? Okay, so I'm going to start by just plotting. Michelle is saying 45. Okay, P is 45. And then also say what A is then. So I'm going to just start by plotting the sine graph, the usual sine graph here in red. And that's why I say it's important that you know the original graph very well, because the original sine graph turns at 90 degrees and then cuts the x-axis at 180. Okay, but we can see that this x-intercept has moved in that direction by 45 degrees. And we can see our turning point has moved also, because normally the turning point of the sine graph is here at 90, but now it's also moved by 45 degrees to 45 degrees. And where the graph normally goes through the origin, the graph has moved 45 degrees as well. Okay, so that is how you know that the graph has shifted 45 degrees to the left. So P is indeed 45 degrees. Now let's have a look at this cos graph. So the cos graph, again, if we just draw the normal cos graph, I'm going to draw it in this light blue color. So the normal cos graph starts here at 1. It cuts the x-axis at 90 and then it turns at 180. So I'm just drawing this little section of the graph that's relevant to us because we are only looking at the graph between negative 90 and 180. And then the same on this side, it will go down and that is what it will look like. Okay. So what we see is actually that, yes, the x-intercept has changed to 90 degrees, but what's also happened is that the graph has stretched out. So it is actually a period change. Well, we know that because the question has already said that A has had an effect. So how do we know by how much? So this is actually, has anyone got it? What did we say here? Has anyone shared it with us? Anyone got an idea what the period change is? A is going to be a half. Okay, A is a half. Well done, answer. You got it. Okay, and then let's go on to question 2. Now give the period of G. So how do we calculate the period of G? We have to take the usual period, 360, and divide it by A, which in this case is a half, and that's going to give me 720 degrees. And then we have to determine the range of K if K of X is f of X minus 1. So if f of X, we now have f of X is, let's just write down what that equation is. It is sine X plus 45. We shifted the graph to the left, so that means we added 45 degrees. Now, if K of X is what f of X is, sine, I will get to the chat just now. I'm going to finish explaining this. Minus 1. So how will we know the range of K? Well, this means we have shifted the sine graph, the sine X plus 45 graph down by minus 1. So if you look at your graph here, which is, it's been drawn for us here, the minimum point is minus 1, but if we shift it down further, it will become minus 2. So your range has to do with your y values. So your lowest point will now be minus 2. And what would have been your highest point, which is 1, has also now shifted down 1. So that will actually now be 0. Okay. So everyone wants me to, or quite a few people, maybe not everyone, wants me to go back to why the period is a half. It has to, okay, so first we have to understand the blue graph, that is the cos graph. That is the normal cos graph. And the period for the normal cos graph is 360 degrees. The normal cos graph will cut the x-axis at 90, but in this cos graph with the period change, we know there's been a period change because the question says so. The question says here cos AX. So that's how we know there's been a period change. So to figure out what that is, we look at actually how long it takes for a wave to complete. So we can see that the normal cos graph, so that's 360 degrees, but this graph, the cos AX, is taking much longer. And how do we know? We look at the 180 and the 90 to see that it's a half. So we take the normal period of the cos graph, which is 360, and divide by a half, which gives our new period, 720. Okay, so it is really important that you relate it to the original graph. Okay, I'm going to go on to some more to the summary, which you are welcome to take down, which will hopefully help you when you study for your tests and exams. because it is almost time for us to start our quiz. So in terms of our transformations, we can shift left and right and up and down. How do we know this? We see it in the equation of the graph, and we look at the period and the amplitude, and always refer to the basic functions. That's basically it. Yeah, you're welcome to take a screenshot of this summary of trig graphs. And I think that is likely all we have time for this evening. Yes, I think we won't have time for that. I can take one or two more questions, and then it is time for the quiz. Ms. Coco, have you got the link for us?
I do. I have it ready.
Great. So that's it, guys. Ms. Coco is going to post the link in the chat for your quiz, and then you can be off and do your quiz on trig graphs, and we will see you back here again on Tuesday for analytical geometry. Thank you, everyone, and good luck.
Okay, Michelle is asking for question 3.
About the range, the question about the range. Okay, so the range of K. So first we start off, so it says K of X is f of X minus 1. So f of X is this graph here, which we said is sine X plus P, and we said P is 45, and we've shifted it to the left. So the actual equation of f of X is sine X plus 45. We've only shifted it horizontally, so its minimum and maximum points are still where they usually are. Okay, I'm just going to clean this up a little bit and take away everything else that we had here, so we can just look at f of X for a moment. So if this is f of X, and its minimum point is going to be here at -1, and its maximum point will be here at 1. So its usual range will be from -1 to 1. Okay, so that's the range of f of X. Now the question is, if I take f of X and I subtract 1 from it and I create a new graph, K of X, then that's what its equation will be. So then think about K of X, and that's basically moving f of X down by 1. So if I move this down by 1, it will actually go all the way down to 0. And this lowest point will go all the way down to -2. So it will look a bit like this. Sorry, it's really bad drawing. But the point is that your lowest point moves down to -2, and your highest point moves down to 0 because you're shifting the graph down by 1. And that's how you end up with -2 as your minimum and 0 as your maximum. Okay. Wonderful. Okay, so your quiz link is in the chat, and you are welcome to give your quiz a go. Anytime, Shay, no worries. All good, King Zooks. It's nice to have had you here for the whole ride, I think.
Yeah, hoping to see everyone here actually in the next
yes
course as well. Which
I hope everyone is back next week
Tuesday.
with
I'm
us.
very excited.